Gas fees have always been a blocker for users interacting with Web3 applications because they've always needed the chain's native token in order to interact with dApps or pay for their gas fees, which can be very stressful. But with the new tool in town, which is the AVNU Paymaster, it doesn't even have to be at all. So whether you are building dApps like the Focus Tree, where all transactions are sponsored, or you want your users to be able to cover their gas fees using any token of their choice, whether be it stablecoins or Ethereum, that's possible with the AVNU Paymaster. It integrates SNP 29, which is the Starknet Paymaster standard. So in this tutorial, I'm going to be walking you through how to integrate the AVNU Paymaster into your dApp using both Starknet.js and Starknet-React to give your users a frictionless experience. So yeah, let's build a smoother onboarding, better UX, and more adoption starting right now. So let's get into it. So for this tutorial, I created a new repository called Paymaster Counter, and I'm going to make this available in the description below. So yeah, the first thing we need to do is that we need to clone this repo to our IDE. I'm using VS Code for my IDE, and when you clone it, you have two folders here: the contract folder and the dApp folder. So for this tutorial, we're going to be implementing a counter dApp. So something very simple that we can all follow along with. So the contract has been built, tested, and deployed on Sepolia, and you can find the address of that contract here in address.md inside the contract folder. So this is the contract address. So you can check it up on Voyager. So yeah, then the main thing is the dApp starter folder. So this is your normal Next.js application. Next.js application using the app router and Tailwind CSS for styling. So let's look at package.json first. So we see the dependencies that are needed firstly. So for this tutorial, I'm going to be looking at how to integrate with both Starknet-React and Starknet.js. So we need some dependencies. So we have to make sure that when trying to integrate this on your own, you always need to make sure that you are installing Starknet-React chains and Starknet-React core version 4. If not, you will not have the AVNU Paymaster feature. Yeah, and also you have to make sure you install Starknet.js version 7.6.4 to have AVNU Paymaster. So yeah, so we have our normal application, and yeah, let us install our dependencies first and foremost. So after our dependencies have been installed, we need to start up the server. So with npm run dev. So if you open it up, so it loads. So yeah, so this is our simple UI for the Starknet counter. So what this does is basically it has three functionalities: to get counts, increase counts, and decrease counts. Currently, only the get count and refresh count works. So yeah, and connect wallet and disconnect wallet works. So here we have the current count to the contract, and we can refresh it. Then we can connect our wallet. I'm going to connect my ready wallet. So yeah, then we have this set amounts dialog box here where we can specify the amount by which we want to increase the count by. So currently the increase and decrease functionality has not been implemented. That's what we're going to be using Paymaster to implement. So the first thing that we need to do is that we need some requirements. So you need to have an env file which has both your RPC URL and a Paymaster API key, which you can currently get by joining the developers Telegram group chat, which I'll be leaving a link in the description also. So you just text them and say that, oh, you need an API key, and they will send it directly to you. So yeah, you have to make sure you have those set up. So the next thing that we need to do is that we need to go to our providers component and set up a Paymaster provider in our provider. So currently in our providers component, we just have a basic setup without the Anvil Paymaster provider in the config. So we just need to do that. So we do that by adding the Paymaster provider prop. It takes in Paymaster RPC provider, which we're going to call, and this takes in an object with RPC, which is an arrow function that returns an object, and this object has node URL first. So a node URL is HTTPS. So this is the one of the
the Sepolia AVNU Paymaster service. Then we have the headers. So the headers is what holds our API key. We have X Paymaster API key like this. So then we take that from our env variable from earlier, process.env dot this, or we have an empty string. By doing this allows us to have access to AVNU's Paymaster globally in our dApp. Let's look at how the contract looks on Voyager. So to get the contract address, you go to the counter contract and go to address.md. So you have the deployed address. Remember, it is deployed on Sepolia. Then you go to Voyager, make sure you are at Sepolia network, then you go to the contract. So yeah, this is the contract. So we can see the read functions in the contract. We have get count, which has been currently implemented in our dApp, because this is the current count 4, and if we query it right here, well, so you see that it returns 4. So in our right contract, we have increase count and decrease count, and it takes in an amount which is U16. So yeah, then we have our ABI already, which has already been imported. So if you go to you see this ABI folder and has counter.api. So yeah, so let's get into implementing increase counts. So we have this increase counts button. We have this component here which is empty, so it doesn't work, so we need to set that up. So when writing to the blockchain, the first thing that we need to do is that we need to create a provider instance in utils. So it can be anywhere, but I prefer to put it in utils. So I'm going to have exports const, let's call it my provider. So this helps us to make calls to our contract. So you can say new RPC provider, and this takes in an object for node URL. So I'm going to pass in our node URL, RPC URL from our env. So we have my provider set up. So yeah, so remember I said that you could use the AVNU Paymaster to allow your users to use any token to pay for their gas fees. So let's look at the supported tokens from AVNU Paymaster. So we're going to increase count. So for the increase count, we're going to be using Starknet-React, but for decrease count, we're going to be using Starknet.js. So we are doing the Starknet-React implementation right now. So the first step was to create our provider instance. The next step is to let's see the supported tokens by Starknet-React AVNU Paymaster. So in order to do that, you have to use Paymaster gas tokens. So this is a hook from Starknet-React, and this returns an object that has data and error. So yeah, so if we try and console or log this data, so let's see how it looks. So you can see the supported tokens for gas fees. So we have this array, so we see the different addresses. So I guess this second one is Stack, the third one is Ethereum, then the fifth one looks like USDC. So the major tokens for gas are either Stack, ETH, or USDC. So yeah, and I have those saved already. As if you go to coin.ts under the lib folder, I have several tokens that we can experiment with. So yeah, those are the available gas fee tokens that we can use in Starknet-React. Now that we've seen the supported gas fee tokens, we can comment this out and we can start working on doing our handle increase functionality. So the first thing that we need to do when we Starknet React is that we need to instantiate our contract first of all. So we get our contract. So this is what we are going to be using to call our functions directly from the contract. So we use contract, and this is gotten from Starknet React, and use contract takes in an object of the ABI So the ABI, remember ABI is gotten, we have an ABI, we saw that ABI here as counter ABI. So counter ABI. So ABI should be counter ABI. Then we have the contract address. We have the contract address, and that is counter contract address. So this returns our contract to us. The next thing that we need to do is that we need to get the chain, and the chain that we're using is Sepolia. So we're going to get the chain, and this is gotten from use network, also from Starknet-React. So as we are typing, it is importing at the top. So the next thing that we need to specify a fee mode. So this is the mode in which we are going to be using the AVNU Paymaster. We can either have gasless or gas free. So by default, it said the default mode is the gasless, which enables us to choose a separate token apart from the native token for gas fees, for users to pay their gas fees in. So we are going to be using, so for the mode, it's an object that has, so we have mode, and this is either default or sponsored, and I'm going to show you how sponsored works later, but we're going to work with default right now. We now need to specify the gas token that we want to use, and the gas token, let's say we want to use it. So it Sepolia from the coins.ts. So this is the gas fee that we want to use for this transaction, the gas fee token that we want to use for this transaction. The next thing that we need to do is that we need to now set up our calls. So this is the call that we're going to be making to the contract. So let's say we're going to use memo, so for better optimization, so our call is not constructed every single time. So if there is no contract or there is no amount, we want to return undefined. I'm going to return undefined. If not, we want to return a call array. So this array is going to have contract.populate. And we're going to, so the function name is increase. I'm going to pass in the function name. So this is increase count. So this is supposed to be in quotations. So it's supposed to be increase count. Then we have the argument. The argument is amount, which is passed in as a prop in these components. So it's not type. So it's supposed to be an array. So an array of arguments. So we only have one argument, which is the amount. So yeah, and this use memo should be reconstructed whenever contract or amount changes. So this use memo is dependent on those. Let me move this up here since we don't need it. So yeah, so we have after setting up our call array, the next, let's call it calls. So the next thing that we need to do is that we need to estimate our gas fee that's going to be used. So and we're going to do that by using use paymaster estimate fees here, and this takes in an object. So it takes in our call, the call that we want to make, and also an options object which has the fee mode. So this will pass in our fee mode. There's an error here because of the fee mode type. So when specifying your fee mode variable here, you need to also attach to the type of fee mode, which is a type that you can import from Starknet directly. So yeah, and that error goes away. So yeah, so the next thing that we need to do is that So this estimates our fees, and it returns. So it returns an object, and it has the following properties. We have data, which we can rename to estimate data. Then it also has a spending, which you can rename to a spending estimate. Then we also have error, which is we can rename to error estimate. I hope I didn't spell anything wrong. So yeah, so after estimating our fees, we need to now send the transaction using Paymaster. So we are going to be making use of use Paymaster send transaction. So this takes in an object. So it takes in the calls array. Then it takes in the option. It takes in an options object which has the fee mode as usual. Then it takes in the max fee in gas token, which you can get from estimate data, which we have above here. Estimate data. Then we're going to take suggested max fee in gas token, like this. So, and this returns an object which we can destructure into. So it takes it can structure into send async. So you'd recognize this from the normal way of sending transactions with Starknet-React. So yeah, so instead of using use send transaction, we're using use Paymaster send transaction. So we have send async, which you can rename to send Gasless. Then we have data, which you can rename as send data. Then we have is pending. So we're going to is pending send. Then we also have error, which we can rename to error send. So yeah, so this is how we send the transaction. Then yeah, so in case you want to wait for the transaction, maybe we're displaying like loading states, we can have use. So this is the normal. We use transaction receipt, which waits for the transaction. So this receives an object that has the hash, which we can get from send data dot transaction hash. Then also takes watch. So this watch is in case the status changes. So this returns an object that we can destructure as usual. So this returns is loading, which we can do wait is loading. So wait is loading. Then we have data, which you can say wait data. Wait data also returns things like status, then is error, then error, like this. So yeah, so this is everything that we need. So now whenever we want to handle increase, we just need to call send Gasless. So here, so in our handle decrease, we can set up like a loading state. We can set up a loading state here. So let's say, so yeah, so in handle increase, we try. So first of all, we set is loading to true. Then we now call send Gasless, like this. So yeah, then we catch in case of any errors. So we console.log that error, see. Then finally we set is loading to false. So yeah, so this is how handle increase works. So whenever the button is clicked, we want handle increase to be called, and it should be disabled whenever wait is loading or pending send or is loading. It is okay, or loading. So yeah, so we fix this disable. So let's see whether it works. So we go back to our server, and so I connect to my browsers and see. So let's say I want to increase the account by 10. So increase by 10. So yeah, so our wallet pops up and we can see the transaction. So yeah, here we are making use of, you see, we are transferring it. So instead of using stack tokens, we can use it directly to pay for this transaction. So we can sign, and I didn't implement the loading states, but if we refresh the page, you can see that our account has been increased to 14. Before we had it at 4. So yeah, this is how it works with Starknet-React. Let's look at the sponsored version. The sponsored version is as easy as just removing gas token from here and using sponsored like this. So yeah, and if we try it again, let me connect again. If we try to increase by one, so this is going to be covered by me, the developer, since I've inputted my AVNU Paymaster key. So if we sign this transaction, so this goes through without any cost to the user. So if I refresh this count, you see that it has increased by 1. So that works perfectly. So I didn't even explain the call. So you notice that here there's no token transfer at all. It's covered completely by the developer. So yeah, so this is useful whenever you don't want your users to pay for gas fees. They just need to come and interact with your dApp completely free. So this is how it works. After implementing the increase counts functionality, we now need to go to the decrease counts functionality. So we go to the decrease counts component here. So remember, for this component, we're going to be making use of the Starknet dApp implementation instead here. So yeah, the first thing that we need to do is that we need to find a way to get the supported tokens in Starknet dApp AVNU Paymaster. So this is different because we're going to be making use of a use effect here, but we need to make sure that we turn this to its client component. So use clients like this. So we have our use effects. So yeah, so let's create a function here. So async function, so get tokens. So let's get tokens, and then here we now get const supported should be equal to await. So the connected account, we get it from user account right here. So account.paymaster. So account.paymaster dot get supported tokens like this. So in case account is not available, we do this. So then we console.log supported here. So console.log supported. So we can now call the function get tokens like this. So yeah, so this is run every time. So this should be run every time account changes. So if we go back, let's see whether. So let's connect our wallets. Let's connect to Bravos, and you see that we have an array of tokens that are accepted here. So this is how you get the supported tokens using Starknet.js. So yeah, so now we can just comment that out, and we can start implementing the call with Starknet.js to decrease count. So the first thing that we need to do is that we need to construct our call array. So this is with const call is equal to, so this is an object. So we have contract address first of all. So contract address. So this is counter contract address. Then we have the entry point. Entry. So this is how you construct with Starknet.js. So for the entry point, we are going to be calling decrease count like this. So that's the name of the function on the contract. Then we have call data. So we have call data. I think it's like this. So call data. So we now use call data from Starknet. So call data.compile. Then we pass in an array of arguments. So in this case, we are passing in an amount only. So this is const. So const calls. So after getting your call, we now need to specify a gas token. So let's say const gas token, and this time let's say we want to use, so let's still use it. It sorry equal to it Seporia like this. So this is the gas token that we want to use. So we now have to construct a fees detail variable, a fees details variable, and this is of type paymaster details, and this is going to be equal to an object. So this is going to have fee mode inside of it, and it also has an object. So we have mode, and we're going to set it to default first of all. So default, then we now have our gas token like this. So yeah, so we are setting our gas token to each Seporia. So that is how we set up the fee details. Then the next thing that we need to do is that we need to get the fee estimation. So remember it from last time, estimation like this. So fee estimation we get, so we await this. So await accounts. So this is the connected users account. So estimate paymaster transaction fee. Then we first pass in the call array. So calls, comma, then the fee details. Like notice that like there's an error with the calls. So I think the error is coming from, okay, I misspelled entry point, so it's supposed to be small letter p, so that error clears away. So we have our fee estimation variable ready. So the next thing we need to do is that we need to execute the transaction. So we are going to be making use of await accounts dot execute paymaster transaction. Then so this takes in an array, so it takes the array of calls, then it now takes in the fee details that we've gotten, then it also takes in the fee estimation. So fee estimation dot suggested pay max fee in gas token. So this is how we get it. Then we now, so after executing the transaction, we now need to wait. So this returns an object that we can destructure, and in that destruction we can get results. We don't even need to destructure, it just returns results. So here, then we need to now wait for the transaction. So in case, so we have const status is equal to await. So we have, so we use, so this is gotten from my provider, the provider we specified earlier, the wait for transaction. Then we have to pass in the transaction hash. So that's stored in results the transaction hash. Okay, so let's maybe put the as string. Let's see whether that works. So yeah, so as string. So we are done with the handle decrease. So let's test it out whether it works. So we can also console.log the results in case you have any errors. So yeah, so it should be disabled. Let's put this to false first, then we can clean that up later. So yeah, so let's try it out and see whether it works. So let's say it wants to decrease by 5. Okay, or let's see, it wants to decrease by 5. So let's try and sign this transaction. So you see, So we can see here decrease counts. We are calling decrease count and we are transferring it. So we're making use of it as our gas fee. So if we sign our transaction, so I think so so yeah, we have current count as 10. So this is for the defaults. So let's look at the sponsored. The sponsored is basically the same thing. We just remove gas token from here, and instead of default we write sponsored here like this. So if we come back here and let's say we want to decrease again by 1, so here, so we sign the transaction. So you see that there's no transfer of tokens. We're just calling the decrease count function. Then we sign the transaction, and if we refresh the count, you see that, so that is 9 now. So this is it doesn't have any loading state to know whether the transaction has been executed or not, but this is basically how it works. So apart from this, also we also have the option to set time bounds. So apart from the fee mode, we can also set a time bound. So this time bound basically is like an optional execution window with execute after and execute before dates. So yeah, and the time unit is in seconds. So you can read more about that in the documentation. So yeah, I hope with this tutorial you've been able to know how to implement the AVNU Paymaster using both Starknet-React and Starknet.js. So you can see how easy and simple it is for you to abstract gas fee for your users. So you can either make use of gasless transactions where they don't need to use the native token for gas fees, or you can use the gas free method, which is the sponsored method, which you pay for the gas fees of your users. So yeah, that is how it works. And if you want more information on the AVNU Paymaster, you can just go to the documentation. So the Starknet.js documentation has been updated, same as the Starknet-React documentation. So I'm going to be leaving all these links below. Yeah, so and I'm going to be pushing my final code to GitHub so that you guys can have like a reference for both the starter and the final files, so you can able to recreate what has been done here. So you can see how easy it is to integrate AVNU Paymaster in your dApp. So yeah, I hope this tutorial was useful. So leave me a comment to let me know what you think. Thank you.